My name is Toshal Dudwala. I'm a senior product manager for ProgrammableFlow. It's been probably over a year since Network Field Day or Tech Field Day team's been to NEC. So what we thought of is to give you a quick update on the enhancement, the features we have done in the product. And then out of those 200 deployments Don talked about, I will cover a couple of real-world deployments we have. And then after that, we'll hand over to for a live demo. So with the version 6.0, I mean, Don covered a lot of that anyway. But the thing I wanted to highlight is the new pay-as-you-grow model with the very low cost of entry point in the SDN with our starter pack with the $3,000. But to top it off, we are also providing a 90-day free trial for anyone who wants to try and have a taste of the SDN in their lab. And with that free trial, they can download our full controller. It comes with the VM and MiniNet, I believe. And then with that, they can try the controller in the lab without having a real switches in the network. And you will be seeing a lot more of the enhancements we have done. I will be covering one, but during the demo, you will see our new web UI with the enhancements we have done over the both product line PFC and UNC. So the first, let me just quickly give you an overview of our PF tab controller. So network monitoring is equally important in the enterprise network with the programmability and network virtualization as well. So we have introduced this PF tab controller. It's based on our PFC controller. That gives us the ability to reuse a lot of the features and the power of the controller, primarily the VTN. And you will hear more about VTN from Arvind later on. But with this now, you have all the traditional features of a network packet broker, such as aggregation, load balancing, flow filtering, redirection of the traffic. But with the SDN now, it allows our customers to have a location-free monitoring fabric. So what I meant by that is, typically the enterprise today, they aggregate their monitoring tools and fabric in one part of the network to reduce the cost and the manageability and complexity of the network. With this now, they can bring the fabric close to the monitoring point, and with the distributed OpenFlow fabric, they can manage that with the centralized location and push the policies in the fabric to redirect the traffic.
When you talk about centralized locations, does that mean that this can be spread out over different locations?
Yes.
How far apart can they be?
In terms of the OpenFlow switches?
Yeah.
Think of it as like it's a typical network. Today we have the ability to manage the switch over the WAN as well.
Mm-hmm. So I can manage like 3 data centers with this?
With one PF tab controller?
Yeah.
No, because you will need 3 controllers in each site. Yeah. All right, so the next feature I wanted to talk a little bit more on, and you'll be seeing a live demo of this as well. So early last year, we introduced our integration with the HyperV, Microsoft HyperV. So NEC launched the very first OpenFlow virtual switch for HyperV solution. It's free to download today as well, so anyone can go and download that switch, install on a HyperV, and now you have a OpenFlow capable virtual switch in a HyperV environment. With the version 6.0, what we have done is we have integrated our controller with the Microsoft System Center Virtual Machine Manager, SCVMM. And with that, it gives the IT operators or the IT admin the ability to manage not just the server virtualization, but also the network virtualization. And what I meant by that is, with the integration with the SCVMM, as soon as the VM is deployed, it triggers the PFC to configure the relevant network policies. And the OpenFlow fabric is automatically configured for those policies required for VM traffic. Not only that, and during the demo, you will be seeing when those VM migrates, the policies are also migrating with the VM as well to the new location. And the last thing I wanted to highlight out of the controller is a new UI. You'll be seeing that in a live demo. But this particular screenshot here shows you the power of the PFC controller with the capability of VTNs. So VTN is our network virtualization solution. where you can see the physical topology, you can track your flows on a physical network, but it also allows you to now view the entire topology in a logical fashion, which is what our VTN capability is. One of the other announcements we did late last year is we introduced a new project. It's called SDN Space. It's an open ecosystem for our technology partners. They can come and work with NEC's OpenFlow controller to develop the SDN applications. So we provide them support, the APIs, SDK to integrate the applications with the controller. And of course, with that, we also work together with the go-to-market strategy or even co-marketing opportunities as well. So this is the list of all the partners as of last month. So we not only have all the data plane partners, which Don talked about before, but now we have a whole bunch of application partners varying from management to security to optimization, WAN optimization as well. Someone also, there was a blog post, I think last week about NFD, I think it was Brandon, I believe, about the application integration. So with this SDN space, it allows our technology partners to really provide that SDN application capabilities to the market. And the last thing I wanted to just quickly cover with the OpenDaylight, so everyone knows here what OpenDaylight is. But with the Helium release, we have also integrated our VTN coordinator. VTN coordinator is our UNC piece, which is our orchestration of controller. And with that, now our customer has the ability to develop the applications on OpenDaylight, or the community can develop the application on OpenDaylight. And then the same APIs are now implemented on our controller. So you can actually port that application on NEC without any modification. NEC is also one of the top contributors to the OpenDaylight project as well.
But that only works if they use the VTN API, right?
Absolutely, yes.
Okay.
Yes.
So you can use OpenDaylight as the test bed. You use the VTN API to develop the application. Then you move that application to PFC.
Yes.
Do you also have the CLI for VTN on OpenDaylight?
I believe no. It's only the REST API.
Okay.
Okay. So that was a quick update on the product. No more questions? I can quickly discuss a couple of the deployments we have in the world, we have in the industry right now. So the first one I wanted to talk is the hospital network. So this customer, their challenge was they wanted to improve the network agility, but they also wanted to reduce the operational cost of the network. Some of the complexity they had in the network, first one was the high availability, because they wanted to make sure there is no downtime risk if there is any upgrade happens during the network. But also they had a lot of different departments, and each department was run by different IT staff. So there was a coordination issue between the staff. Also a long lead time, because if you want to roll out a service, you have to coordinate between all of them. And it was making very complicated to given the addressing in the system as well. And this actually prevented them to have the new services introduced in the network. So again, NEC came in. We designed the network, and with that, we put all the services in a centralized location in a data center network. And then we built a layer 2 fabric, the distribution network, and we connected all the various departments via our VTN capabilities. And that distribution network allowed the hospital to connect various equipments and smartphones and medical staff and various departments. And with that, they have now a highly available network, but that also allowed them to quickly roll out the new services. Some of the services they roll out was a biomonitoring for patients' data. But not only that, they were also able to start saving some cost, their operation cost, by reducing the number of equipments they have in the network. So that was the first use case. The second one is the Tokyo train station. So as you probably would know, Tokyo train station is one of the world's biggest or largest train station, not in terms of size, but also in terms of the daily traffic as well. They have over, I believe, 13 different train lines. So their complexity is where the train station is the network was such old, it was built over time. A lot of wiring, very hard to make any changes. And even if they want to make changes, they only have a very small window between 3 a.m. to 5 a.m. overnight. And also, whenever they're making changes, network was such a complex, they had a cascade effect. And it was making them very difficult to roll out any new services. So again, we have created a distribution network, a flat layer 2 network. So we have ripped up all the network and we put a brand new network, OpenFlow based network distribution. And then we instantiate the various services. So we have 6 different services now they have. And those services are shared amongst various users, either station staff or to the general public via their smartphones or applications, online applications. And that allowed them to now have a completely redundant network. They were able to quickly roll out the new services. And not only that, now they can make changes from a centralized location. Some of the new services they've deployed is they are now able to use an IP camera to monitor the station traffic, and they can make changes on the fly in terms of the station and train arrival time, arrival locations. So again, they improve a lot of the agility in the network with our solution.